Every single year, thousands of Cambridge IGCSE computer science students drop absolutely crucial marks on paper 2. And look, it's not because they don't understand programming. It's actually because they don't know how to speak the examiner's language. So if you want to stop bleeding points on simple concept questions, you're exactly where you need to be.
Think about this for a second. Which definition of an IDE is actually going to earn you full marks on your computer science exam? I'll tell you right now, 2 of the most common answers students give are complete traps. They might look totally fine to the untrained eye, but writing them down will absolutely cost you a grade boundary.
Let's look at the options. Number 1, a place to write code. Number 2, software that helps programmers design, create, and test code. Or number 3, a graphical user interface. Let's knock out those traps right away. Option 1, way too vague for the Cambridge mark scheme. And option 3 is just factually inaccurate. Sure, an IDE definitely has a graphical user interface, but that isn't what it fundamentally is. Writing either of those on your exam paper is a guaranteed 0.
Section 1. Unlocking the IDE. What exactly is Visual Studio 2019 Community?
Okay, let's dive into this. To make sure you never fall for those traps again, we really need to lay down the technical foundation for what an IDE actually is, specifically looking at the tool you'll be using, Visual Studio 2019 Community. Here's the winning answer from our earlier question. An integrated development environment, or IDE, is software that helps programmers to design, create, and test program code. You need to memorize this exact technical wording. This is the Cambridge SAFE framework that locks in your marks. Seriously, don't improvise here. Stick to those specific verbs: design, create, and test.
So how does this actually apply to your specific syllabus? Well, Visual Studio 2019 Community is Microsoft's free IDE. Its core job is to generate programs and translate your high-level Visual Basic code into binary. And that translation to binary, that's what actually makes your code executable by the computer. Without it, your code is just, useless text sitting on a screen.
Section 2. Console versus Windows Forms. Choosing the right application mode.
When you open Visual Basic, you're hit with 2 very different application modes. And honestly, misunderstanding them is a classic pitfall I see students make all the time when preparing for their exams. Let's break down the comparison. On one side, you've got the console application. This gives you a textual interface. It's completely uncluttered and runs right from the command line. On the flip side, a Windows Forms application gives you a full graphical user interface, offering a much richer visual experience. And this brilliantly illustrates the difference between learning raw programming logic versus building commercial-style software.
But listen up, because here is a massive warning straight from the Cambridge IGCSE programming book. Quote, Windows Forms application is optional content. It is not covered in the syllabuses. End quote. If you spend your time memorizing Windows Forms code for the exam, you're going to earn absolutely 0 marks. No way around it. However, in just a few minutes, I'm going to share a hidden secret about Windows Forms. It actually has a massive benefit that can drastically improve your Paper 2 score. But first, you need the framework that makes that secret work.
Section 3. Mastering VB data types and translating pseudocode to Visual Basic.
All right, let's shift into our practical toolkit. Examiners aggressively test your ability to translate abstract pseudocode into actual Visual Basic data types. You literally have to know the precise differences or your code simply won't compile in the examiner's eyes. This translation guide is your best friend. Think about fractional numbers. In pseudocode, you use real for that. But Visual Basic does not use the term real. It expects decimal. If you write real in a Visual Basic syntax question, you lose the mark immediately. Boom, gone. For characters and text, thankfully, char maps perfectly to char and string maps right to string.
Now, there are some pretty strict rules governing the char data type. It uses exactly 2 bytes of memory to store a single Unicode character. But here's the classic exam trap you need to watch out for. If your char holds a digit, let's say the number 6, you absolutely cannot use it in a mathematical calculation. If you try to multiply that 6, it's going to instantly break your algorithm. Why? Because the computer sees it as a text symbol, not a mathematical value.
16. Keep that number locked in your head. The decimal data type uses 16 bytes of memory. Unlike a tiny 2-byte char, decimal is designed to securely hold massive positive or negative fractional values, things like real-world currency. And examiners love to test if you know which data type is appropriate for a given real-world scenario based strictly on these memory constraints.
Moving right along to strings. A string holds words or complete sentences. And get this, it can store up to an astonishing 2 billion Unicode characters. That's huge. So the crucial point to remember is this.
Whenever you pass textual data to a string or a char, it absolutely must be placed inside straight double quotation marks. No quotes, no marks. It really is that simple.
Section 4. Acing the Exam Question. The Mark Scheme Masterclass.
We've got the theory down. Now, let's elevate the stakes and shift into elite exam coaching mode. It's time to bridge the gap between raw knowledge and actual exam application. To construct a top-band response, you need a highly structured concept-to-exam pipeline. Just follow this 4-step framework. Step 1. Give the exact definition. Step 2. Explain the mechanism of how it works. Step 3. Apply it directly to the scenario example provided in the question. And Step 4. Validate it using precise examiner wording. Let's see how this looks in action.
Check out this painfully common, really weak student answer. A string is for text and a char is for a letter. You write code in Visual Basic to make a GUI. Ouch. Let's treat this explainer like a live red pen marking session. Why does this answer fail so miserably?
Let's diagnose the damage here. First off, the IDE definition is missing entirely. Saying you write code to make a GUI is horribly weak and just inaccurate. Second, it completely fails to mention string syntax like those necessary double quotation marks we just talked about. Third, it confuses char constraints by vaguely saying for a letter instead of specifying a single 2-byte Unicode character. And finally, it mentions GUI without any context at all, completely ignoring whatever scenario constraints were actually in the question.
Now, let's look at the upgraded answer, applying our 4-step framework. Visual Studio Community is an IDE that translates code. Strings hold up to 2 billion characters in double quotes. Chars hold single 2-byte Unicode characters. Look at how beautifully dense that is. We've got the exact definition, the mechanism, precise constraints, and examiner-approved technical vocabulary. That right there is exactly how you perfectly follow the pipeline to secure maximum points. And that brings us right back to the Windows Forms secret I promised you earlier. Why would the textbook even mention Windows Forms if it earns 0 marks on the syllabus? Well, because while it's not tested directly, building a richer visual experience actually accelerates the development of your computational thinking. Seeing your variables and data types operate inside a visual interface physically trains your brain's logic centers. It gives you those abstract problem-solving skills you desperately need to ace the rest of Paper 2.
So what happens to your perfectly structured Visual Basic code when an examiner tests it with extreme boundary data? A flawless algorithm on paper can instantly crash in the real world if you don't know how to validate and test for edge cases. If you want to know exactly how to bulletproof your code against the examiner's trickiest boundary data, you need to watch our next explainer immediately. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations.